Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on Building Energy Systems and Auditing. In the module 7, the third lecture will be delivered today. We are in the lecture number 33 and we will discuss about the star rating of shopping malls and BPOs. So, in this we will discuss this too EPI values, how to calculate for the shopping mall and the BPO. It is will be very similar to what we have discussed in the lecture number 32, and also we will see the two different type of the indexing system of EPI and AAH EPI here. So, in the beginning in the shopping malls also the Bureau of Energy Efficiency has recommended 1 to 5 scale for a star rating scale based on the EPI values, and that is depending upon the this 4 climatic zone. Perhaps they may go for further in other climatic zone of India. I mean to say that this one of the climatic zone is left, that is the cold climate. The only difference is in this particular the system is that we will calculate the EPI straightforward values, and from the straightforward the EPI values the star rating will be decided without any kind of consideration of the percentage of the air conditioned areas or so. So, again let us briefly discuss about the EPI, that is the energy performance index of any building, that is measured in kilowatt hour per square meter per year kind of the evaluation. So, yearly total amount of energy required to run the building, to operate the building has to be calculated, and then we have to actually divide that one by the total active the built up area, and then this particular EPI is going to be found out. So, the energy performance index, the bandwidth has been prescribed by the Bureau of Energy Efficiency, Government of India, for composite climate, all the 4 type of climates. So, composite climate, it is this bandwidth is, suppose it is 350 to 300, then it is given as the 1 star, as we also discussed in the earlier. If it is more than 350, then it will not going to get any kind of a star rating, and if it is below 150 or so, then it will be given as the 5-star rating systems or so. So, that is for the composite. If you see the hot dry, it is little bit I may say is little tight. The first the 1 star rating will be 300 to 250, whether if any building is situated in the hot and dry climate and want to take the 5-star rating. So, the operational energy EPI index must be below 100, whereas if you see in the composite climate, it is below 150. Similarly, the warm and humid climate is below 250 is the 5-star. So, it is much more relaxed in that sense, or in the other way, if you see if you actually want to see into the other perspective, it is little tougher to control or you have to actually your expenditure of the air conditioning and all these things is much higher with in the warm and humid climate, which is obvious because we have to also look after the humidity part also. And the temperate climate, if it is below 175, then only it will be given as the 5-star. So, these are the typical the bandwidth, and this is a straightforward as I told, because this does not depend upon the percentage of the air conditioned area, which was earlier mentioned for the office building or so. And this is prescribed till date. It may change in the in some coming years, because the Bureau of Energy Efficiency changes this thing. Last 10 years I have seen there are at least 2 times changes in this particular bandwidth, or how to calculate that one for the EPI calculation and the nomination of the stall level. They have changed twice. So, let us discuss one small problem with a shopping mall, which some data is given. This has 3 zones. The ground floor, first, second and third. So, there are G plus 3 floors, and there are zone 1 and zone 2 is air conditioned. So, I have mentioned the TR per meter square values for zone 1 and zone 2. Zone 3 does not have anything. So, that means it is a non air conditioned zone. The lighting load in all the 3 zones are mentioned, 10 watt per meter square, which is your LPD value, lighting power density value. The first zone it is 10 watt per meter square, the second zone it is 12, and third zone it is 8 watt per meter square, and the area distributions in meter square is also given. So, and this particular shopping mall is situated, let us suppose it is situated in Visakhapatnam, which is a warm and humid climatic zone of India. So, based on that, let us see other data which has been given for this particular building, maybe that can come out from the energy audit. The first one is that the shopping mall will definitely will have a food court. That food court require 30 liter of LPG per day, and a additional DG set, diesel generator set is installed in that particular particular shopping mall for the lighting the parking and garden area. So, that is garden area which require 10 liter of diesel per day for. So, the lighting of the parking and the garden areas, landscape areas is generated by this diesel generated set. There are 4 escalators which are having 150 kilowatt hour rating operative that operate for 3 hours, you may say, for the whole day. And there are open parking which estimated as almost about 2000 meter square area, but these are all false. This particular one is a very false data. False data in the sense it is true data, but that is not going to actively participate in the calculation, because as per the definition we have to actually take the area which are the building the built up area which does not include any lawns, and does not include any kind of the parking areas also. So, even those the values are given to you, you should not take into account for the calculation, that has to be. So, I will say that this, I will just make a cross mark that it will not going to use for the calculation. The next one is the shopping mall generates 650 kilowatt hour solar energy to compensate its daily electricity requirement from the power grid. So, whatever power grid has been given, or it was taken from the power grid, which is maybe actually seen as the air conditioning load and the lighting load. Out of that 650 kilowatt hour solar energy per day is harvested in that particular mall through the maybe the rooftop the PV cells. We have to assume that it will work for 12 hours per day, and the shopping malls takes almost every month, every day it will be open. So, we will take as assume as almost like 30 days in a month for my annual calculations, and those calorific values, everything has been given. So, now let us start the solution. How we will go step by step. You have to be very meticulous while doing those problems, and we have to make some kind of the logical understanding and go step by step. Please do not go for the jumping the steps. It may reduce the time to solve the problem, but sometimes it may involve many errors. So, what I will do, I will first calculate all the areas of different zones, these 3 zones. So, I have calculated zone 1 area as 3400 square meter and zone 2 as 3900. So, these are the, if you add up, this will be 3900. If you add up, this will be your, the summation will be 3400 like that, and this will be 2300, the summation of the zone 3. So, these 3 I have added first, and then I have added all these 3 to find out the what is the total built up area. So, that is very important, because I need this one to calculate the EPI at the fag end of my calculation or my the steps. But please remember, those 2 data I am not going to use, that was the parking area and the lawn area, which is mentioned in the problem, but that I am not going to use. Let us go to the next step. So, first of all, let us find out the air conditioning load. So, zone 1 and zone 2 are under air conditioned area. So, the areas are mentioned 3400 and 3900 in from the first step, and the how much is the tonnage of refrigeration per meter square is given. So, I can directly multiply these two. So, this is the first area, the area of the first zone, the intensity of the air conditioning for the first area, plus the second area is this one, and the intensity of the air conditioning for the second area. Why I multiply with 3.5? It is now must be very clear to you, because 1 TR is equal to 3.5 kilowatt, and so I have, after this 3.5 multiplication, it is now come down to a kilowatt unit, and it operates per day to 12 hours. So, if I multiply with 12 hours, so this like this 5922 kilowatt hour per day will be the requirement for the air conditioning. So, in this problem, it was not mentioned that this air conditioning load, how it fluctuates. Mostly in the building, it will going to fluctuate in the summer and winter, or maybe the normal months, there should not be the same, but let us hope, or let us assume that at least for this particular problem, I have not make it little complicated. So, it is for the average requirement for the year, and the annual air conditioning load is now calculated with multiply by 30 and 12, because it is a 30 days a month and 12 month a year, and that format. So, a total of 21,31,920 kilowatt hour is total requirement for whole year only for air conditioning. So, next we will go to the lighting calculation. So, lighting calculation, all the 3 zones now we will have to take for this calculation, because lighting loads or the LPDs are mentioned for the 3 different zones, 3 different values. So, I will first multiply the zone area and corresponding LPDs 10, 12 and 8, and then I multiplied that, and that will come in a watt, because the intensity of the lighting load is given in 10 watt per meter square. So, if I multiply with meter square, it will be watt. So, this is big number. If I multiply that with 12 hours, because it will work for 12 hours. So, whatever will come, big value is the watt hour, and then I divide that by 1000. So, I will get the 1190.4 kilowatt hour lighting load per day. That is a per day requirement. Again, like the earlier one, I will multiply that with 30 and 12, just to see how much is the total the lighting load for the annual on the annual requirement or so. So, it is coming out to be 4,28,544 if my multiplication is correct, probably it is correct. So, these 2 major things I have been calculated. The AC load is about 21 lakhs something, and the lighting load is 4 lakhs, much less, but still it has to have some kind of impact. Now, the other loads that like food court and all, because a building is functioned not only with the energy is not only required for the air conditioning and the and your lighting, it required for instruments, for equipment, for some kind of water pumping, the escalators, lift, and this malls are having going to be a food court, and also there are multiple requirements. So, for that we have to take one and other, each individually treat them in a different way, because something I get it for per day, something may I get it for month or week. So, the food court required 30 liter per liter of LPG per day. So, first this 30 liter will be converted to kilowatt hour. So, that is 6.94 kilowatt hour per liter is the LPG value. So, I got this value 208.2 kilowatt hour per day. Again we have to multiply that with 30 and 12. So, we will do later, and this is the additional DG set which has to be give lighting in the parking areas and the garden areas, that require 10 liter of diesel. So, the 10 liter of diesel the conversion factor is almost about, calorific value is almost about 11.11 kilowatt hour per liter. So, I have multiplied that into 11.1. So, I got 111.1 kilowatt hour per day. So, these two are calculated per day, and then there are 4 escalators which operates for 3 hours. So, that is also multiplied by 4, 150 kilowatt is multiplied by 4. There are 4 numbers and they are operating for 3 hours per day. So, 1800 kilowatt hour per day is the energy required for to run the escalators, average the requirement. So, those are per day. So, I have added those 3 and I have multiplied that into 30 and then again with 12. So, make it in annual scale. So, that gives almost like 7,62,948 kilowatt hour is the annual requirement. So, let me check with this problem once again. So, this problem once again, if you see, the additional DG set which require 10 liter per day diesel is for the parking and gardening. So, you may say that I am not taking the parking and the garden area for calculation, but why should I take this DG set require 10 liter per day petrol or diesel to light those? No. So, we may not take, or as per the definition we are not going to take the parking area and the lawn area, but any energy is going to be expenditure on these 2 areas, maybe for lighting, maybe for some kind of washing, for pumping water or whatever, maybe for those areas or so, that has to be included, because that is the integral part of the functioning part of the building, but the areas cannot be taken into account. So, that you please remember. So, now this 3 has to be added, this 3, the annual energy for required for the air condition is 21 lakh something, annual lighting load is 4 lakh something, and the other annual energy consumption is 7 lakh something. This 3 has to be added, and that has been added, and that has been finally found out that 33 lakhs 23,412 kilowatt hour is the tentative, the annual the energy required for this shopping mall. Okay. So, so this is the annual. So, now I know the area, area is okay. Now, another step I have to made, yes, this is the I have forgot. So, I have to made it. So, that is the we have given one point in the description of the problem is that the shopping mall generates 650 kilowatt solar electricity per day. So, whatever is required this particular requirement is the total requirement, 33 lakhs is the total requirement. Out of that something is generated from the solar and rest is your the grid or and petrol and all those. So, I have to deduct that one, because the total consumption of the energy should not include the RE generation, from the RE source, renewable energy source. So, if it is 650 kilowatt per day, so again I multiply with 30 and 12. So, a sleek amount, almost about 2,34,000 kilowatt hour amount of energy I can say I can harvest from the solar energy as a solar energy throughout the year, and that has to be deducted from the total requirement. So, that means 33 lakhs something is the total requirement. Out of that 2,34,000 is the generated by the renewable energy source. So, that means this 33 minus 2 whatever, and that means the 30 lakhs 89,412 kilowatt hour is the energy expenditure through grid and through some generated activities through the petrol, diesel or maybe some other activity other fuel. So, that has to taken into the calculation. So, total minus the RE. So, that is from the grid and plus something, not only grid plus some other sources or so. Okay. So, other non RE sources you may say. So, this 30 lakhs 89,000 is my number, and this number has to be divided spreading. This number is what number? This number is the amount of electricity or the energy required from the non RE sources throughout the year annual, and this is the 9600 square meter is the total built up area of the building. So, if I want to find out this EPI is coming out to be this 30 lakhs 89,412 divided by 9600 meter square. So, that gives me almost about 322 kilowatt hour meter square per year. So, that is the footprint, that is the EPI of this particular shopping mall situated in a location which is a which is a warm and humid climatic zone of India. So, this is my table. So, I have to see that where it falls, it is 322. So, it is somewhere there, it is in between the bandwidth of 350 and 300, isn't it? 322 comes in between the 350 and 300. So, as per this particular recommendation by BEE, this particular shopping mall will get 3-star rating. It will get 3-star rating, and then it may further improve by virtue of some additional cut downs or maybe some additional regenerations or so, then it may go to 4-star or 5-star. So, then you have to be little bit, if they go a little bit below, maybe 22 kilowatt hour below per year per meter square. So, then it may get 4-star rating or so. So, this is the way that we calculate for shopping malls, but please remember here what is the change with the earlier problem for the office building we have discussed in the lecture number 32 is that here we have not considered the percentage of the air conditioned area, okay, and that particular equation table, that y equal to mx plus c table is not there. It is straightforward, the bandwidth is given and from there we have to select, but I have told you perhaps in the future, near future, the BEE may come up with some further recommendation with the divisional criteria of the percentage AC area or some other kind of the classification. So, you have to be very thorough about that. You have to be visit their website, BEE website time and again to update yourself in this regard. So, next we will discuss the BPO, that is the business promotion, the outsourcing cases, or in general we can say it is the IT, the information technology buildings, which operates in a different way. So, they means I may say that the Bureau of Energy Efficiency, they have some other type of recommendation, because this also comes under a maybe office building or maybe a commercial building, but as their operations, the nature of operations and all is quite different from some other normal office buildings, or so maybe from a bank or maybe from a government office or maybe any kind of corporate office. This is not the same. They work for 24 hours, there intense amount of air conditionings or so. They may have non air conditioned areas also, probably look for the for other areas, for some supporting areas or so. So, they have come across another set of recommendation for star level for these BPOs and the IT offices. Again here they are recommended for these 4 warm, humid, composite, hot, dry and the temperate climatic zone of India. Very similarly in the office buildings and also for the shopping malls, we can only evaluate the star rating systems of the buildings which are who are connected with a load of 100 kilowatt or more. 100 kilowatt is nothing. So, always most of the buildings will become above this 100 kilowatt. So, here very similarly we will do first the EPI, there is no change in the calculation. So, you see this formula is very similar, it is something like the same formula, the electricity purchased and generated per year or annual excluding the RE generation on the source divided by the built up area, which you do not exclude any kind of road, any lawns, any parking, etc. So, that is fine, but after that they have recommended another the criteria, not criteria, and further purify or modify that index to AAH EPI. So, the EPI is now AAH EPI, which is average. First A stands for average, then next A is the annual, and the H is hourly. So, if you see the unit, if you remember the first EPI unit, if I say EPI, the EPI is kilowatt hour per meter square per year, right, annual. But AAH EPI is what? First of all, this is watt hour, watt per hour, and that is in per meter square annual. That has to be calculated. So, what I can do? I can actually multiply this EPI value by 1000 first. Why? If I multiply that by 1000, this value become the watt hour per meter square. This is annual. So, let us suppose this is annual case, and then I will divide that by the daily operation of the days, which is the daily operation of the days multiplied the days of the week, and there are 52 weeks in a year, something like that, and then that will be actually driven to the watt hour per hour or something like that. Per hour, how much watt I am consuming per meter square of the area. Okay. So, that way we can actually find out. So, I have taken another problem, a BPO work in Chennai, it is 24 into 5 more, that means 24 hours working and the 5 days per week, and it has a 7000 meter square of the area. 5000 meter square is IT office, which is going to be the air conditioned, and rest 2000 is the service areas also, and total number of staff working in 1000, and air conditioned load in the IT office is found 2.005 TR per meter square, and the lighting loads are IT office is 14 and the service area is 10 watt per meter square. The equipment load is estimated 1.5 kilowatt hour, and there is again a diesel set and food court and all whatever is there. So, based on that I have to calculate, this is in Chennai. So, warm and humid climate, the diesel and the LPG conversion rate is given there. This is also the harvesting 150 kilowatt energy of the energy which used for the parking light and garden light. So, this again will not come into any calculation, because those are not come into the calculation. Whatever the here in the beginning we have discussed, that will come into the calculation, because that is non renewable energy sources, and we have to find out what is the ranking. So, straightforward, it is very straightforward. We first found out the air conditioned load. So, the 500 meter square area under air conditioned of this 0.005 TR per meter square, 3.5 is the multiplication factor, 24 hours for a day. So, almost like 2100 kilowatt hour is the energy required for a day. Lighting is also calculated, 5000 is 14 LPD and 2000 is the 10 LPD, and that is also multiplied by 24, because 24 hours is working and then divided by 1000. So, that makes to the kilowatt hour. Equipment load is also for 1000 people. So total daily consumption is 5460 kilowatt hour. Okay. So, that is very simple. So, then we have diesel and all those kind of a thing. So, diesel gives me almost about 750 kilowatt hour per month. Please remember, this is per month, and the LPG is again per week, 2000 something is per week. So, now we make it annual, yearly consumption of the daily. So, finally, just multiplying this is the monthly consumption by 12. So, I have to multiply with 12 and the weekly consumption with 52, because we assume that 52 weeks a year. So, we got these 3 big values, which is has to be added up for a yearly calculation. So, we can find out that this is the some 15 lakh 68,000 kilowatt hour plus something kilowatt hour is the total consumption for yearly. Built up area is 7,000 and EPI is this 2 divisions, so it is 224. But we cannot stop here, because we have to go with the AAHPI. So, this is annual operating hour have to be first calculated. How much is the annual operating hour? 24 hour per day. So, I think I have written down 24 hour per day, 5 days a week and 52. So, in a year this BPO is working for 6240 hours by virtue of the 24, 5 and 52 weeks. So, this is divided by that and multiplied with 1000. So, I got 36 watt per hour per meter square is the footprint, per hour footprint. Please remember that one EPI is per year footprint and it is the per hour footprint, and that is why instead of what? Instead of the kilowatt hour, now it is in watt hour. Okay. So, this is the change what we have noticed from the absolute EPI to AAH EPI. Now, we have found out the percentage of area 71.4%, because 5000 meter square area out of 7000 is the air conditioned area, and now we can go to straightforward to this the table, which is very similar to the table for the office building, where x represent the amount of the air conditioned area, and here this is the warm and humid climate. So, for each these 4 or 5 equations, I put x as 71.4, yes, 71.4, and I have calculated this bandwidth. These are the bandwidth, and my value is 36. So, definitely it is in this. So, I can give a 3-star rating of this particular BPO. So, if it is little less 30 or less than 30, I can give it 4-star. If it is less than 23.5, it is 5-star. So, that way it is calculated. Only change is that is you have to convert the EPI to the hourly average, the annual the hourly EPI value, which we have to divide that by the total the operating hour of the office building also. So, in conclusion, we have seen that the how to measure the EPI values for the commercial building like the shopping mall and the BPOs, and EPI is the modified AHP is modified as the AH EPI in case of the BPO or the IT officers. Thank you very much.